Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You need to design a solution for global load balancing based on the URL path being requested. You need to ensure operations reliability and end-to-end in-transit encryption based on Google best practices. What should you do? The options are: Option A, create a cross-region load balancer with URL maps. Option B, create an HTTPS load balancer with URL maps. Option C, create appropriate instance groups and instances. Configure SSL proxy load balancing. Option D, create a global forwarding rule. Configure SSL proxy load balancing.
To arrive at the correct answer, we focus on the keywords: global load balancing, URL path, end-to-end in-transit encryption.
The correct answer is option B. Create an HTTPS load balancer with URL maps.
Why is this correct? B. An HTTPS load balancer operates at layer 7, supporting URL maps for path-based routing while enabling end-to-end in-transit encryption from clients to back-end services. Why are the others incorrect? A. Cross-region load balancer is an imprecise term. The standard GCP product required for HTTPS URL path-based routing and encryption is an HTTPS load balancer. C. SSL proxy load balancing operates at layer 4, TCP, and cannot perform HTTPS URL path-based routing. D. SSL proxy load balancing operates at layer 4 and lacks the ability to inspect HTTP request headers or URL paths for routing decisions.
You have an application that makes HTTP requests to cloud storage. Occasionally the requests fail with HTTP status codes of 5XX and 429. How should you handle these types of errors? The options are: Option A, use gRPC instead of HTTP for better performance. Option B, implement retry logic using a truncated exponential backoff strategy. Option C, make sure the cloud storage bucket is multi-regional for geo-redundancy. Option D, monitor https://status.cloud.google.com/feed.atom and only make requests if cloud storage is not reporting an incident.
To arrive at the correct answer, we focus on the keywords: cloud storage, HTTP status codes of 5XX and 429. Handle these types of errors.
The correct answer is option B. Implement retry logic using a truncated exponential backoff strategy.
Why is this correct? B. Google Cloud recommends implementing truncated exponential backoff retry logic for transient errors such as HTTP 5XX server errors and 429 too many requests. This gives the service time to recover and prevents overwhelming the API with immediate repeated requests. Why are the others incorrect? A. Switching protocol to gRPC does not resolve rate limiting or transient server errors, which still require proper retry handling. C. Multi-regional buckets increase availability across geographic regions but do not handle or prevent transient 5XX or rate limiting 429 errors for individual HTTP requests. D. Checking the status feed introduces delay and does not handle instantaneous transient errors or rate limiting issues specific to your application's request volume.
You need to develop procedures to test a disaster plan for a mission-critical application. You want to use Google recommended practices and native capabilities within GCP. What should you do? The options are: Option A, use Deployment Manager to automate service provisioning. Use activity logs to monitor and debug your tests. Option B, use Deployment Manager to automate service provisioning. Use Stackdriver to monitor and debug your tests. Option C, use Cloud Scripts to automate service provisioning. Use activity logs to monitor and debug your tests. Option D. Use cloud scripts to automate service provisioning. Use Stackdriver to monitor and debug your tests.
To arrive at the correct answer, we focus on the keywords: test a disaster plan, mission critical application, Google recommended practices, native capabilities.
The correct answer is option B. Use Deployment Manager to automate service provisioning. Use Stackdriver to monitor and debug your tests.
Why is this correct? B. Deployment Manager provides infrastructure as code to declaratively and reliably automate environment replication during disaster recovery tests. Stackdriver, cloud logging/monitoring, offers the required real-time metrics, logs, and observability tools to effectively monitor and debug test execution. Why are the others incorrect? A. Activity logs only record administrative actions and configuration changes. They lack the comprehensive performance metrics, application logging, and debugging features that Stackdriver provides for observing system behavior during a test. C. Imperative cloud scripts are harder to maintain and less reliable for environment replication than declarative infrastructure as code tools like Deployment Manager. Furthermore, activity logs do not offer comprehensive monitoring and debugging features. D. While Stackdriver is correct for monitoring, using imperative cloud scripts is suboptimal and less scalable than using declarative Deployment Manager templates for disaster recovery automation.
Your company creates rendering software which users can download from the company website. Your company has customers all over the world. You want to minimize latency for all your customers. You want to follow Google recommended practices. How should you store the files? The options are: Option A. Save the files in a multi-regional cloud storage bucket. Option B. Save the files in a regional cloud storage bucket, one bucket per zone of the region. Option C. Save the files in multiple regional cloud storage buckets, one bucket per zone per region. Option D. Save the files in multiple multi-regional cloud storage buckets, one bucket per multi-region.
To arrive at the correct answer, we focus on the keywords: customers all over the world, minimize latency, Google recommended practices.
The correct answer is option A. Save the files in a multi-regional cloud storage bucket.
Why is this correct? A. Multi-regional cloud storage optimizes performance and minimizes latency for globally distributed users by storing data redundantly across large geographic areas. Why are the others incorrect? B. Regional buckets store data within a single geographic region, causing higher latency for international users. Furthermore, cloud storage buckets are regional or multi-regional, not zonal. C. Creating regional buckets per zone and region adds severe operational complexity and fails to leverage cloud storage's built-in multi-region georeplication. D. Manually maintaining multiple multi-regional buckets introduces unnecessary administrative overhead compared to using a single multi-regional storage bucket.
Your company acquired a healthcare startup and must retain its customers' medical information for up to 4 more years, depending on when it was created. Your corporate policy is to securely retain this data, and then delete it as soon as regulations allow. Which approach should you take? The options are: Option A. Store the data in Google Drive and manually delete records as they expire. Option B. Anonymize the data using the Cloud Data Loss Prevention API and store it indefinitely. Option C. Store the data in cloud storage and use lifecycle management to delete files when they expire. Option D. Store the data in cloud storage and run a nightly batch script that deletes all expired data.
To arrive at the correct answer, we focus on the keywords: retain its customers' medical information for more years, delete it as soon as regulations allow.
The correct answer is option C. Store the data in cloud storage and use lifecycle management to delete files when they expire.
Why is this correct? C. Cloud Storage Object Lifecycle Management provides built-in rules to automatically delete objects based on their age or creation date, satisfying the compliance requirement securely without custom code or manual intervention. Why are the others incorrect? A. Google Drive is meant for individual file sharing and collaboration, not enterprise-scale compliance storage, and manual deletion is error-prone. B. Anonymizing data and keeping it indefinitely violates the explicit corporate policy to delete the medical records once regulations permit. D. Running custom nightly batch scripts introduces unnecessary operational overhead and risk of failure compared to using native object lifecycle management.
You are deploying a PHP App Engine standard service with Cloud SQL as the backend. You want to minimize the number of queries to the database. What should you do? The options are: Option A, set the Memcached service level to dedicated. Create a key from the hash of the query, and return database values from Memcached before issuing a query to Cloud SQL. Option B, set the Memcached service level to dedicated. Create a cron task that runs every minute to populate the cache with keys containing query results. Option C, set the Memcached service level to shared. Create a cron task that runs every minute to save all expected queries to a key called cached_queries. Option D, set the Memcached service level to shared. Create a key called cached_queries, and return database values from the key before using a query to Cloud SQL.
To arrive at the correct answer, we focus on the keywords PHP App Engine Standard, Cloud SQL, minimize the number of queries to the database.
The correct answer is option A, set the Memcached service level to dedicated. Create a key from the hash of the query, and return database values from Memcached before issuing a query to Cloud SQL.
Why is this correct? A. Dedicated Memcached ensures consistent performance and capacity. Hashing individual queries creates unique cache keys, allowing the application to check and return cached database values before querying Cloud SQL, successfully reducing database load. Why are the others incorrect? B. A cron task running every minute cannot dynamically cache user queries on demand and inefficiently handles real-time data needs, risking stale data. C. Shared Memcached does not guarantee cache capacity, and saving all query results under a single key via cron creates severe performance bottlenecks and size limits. D. Storing all query results under a single key, cached_queries, in shared Memcached leads to race conditions, key size threshold issues, and inefficient retrieval.
You need to ensure reliability for your application and operations by supporting reliable task scheduling for compute on GCP. Leveraging Google best practices, what should you do? The options are: Option A, using the cron service provided by App Engine, publish messages directly to a message processing utility service running on Compute Engine instances. Option B, using the cron service provided by App Engine, publish messages to a Cloud Pub/subtopic. Subscribe to that topic using a message processing utility service running on Compute Engine instances. Option C, using the cron service provided by Google Kubernetes Engine, GKE, publish messages directly to a message processing utility service running on Compute Engine instances. Option D, using the cron service provided by GKE, publish messages to a Cloud Pub/subtopic. Subscribe to that topic using a message processing utility service running on Compute Engine instances.
To arrive at the correct answer, we focus on the keywords reliability, reliable task scheduling, Google best practices.
The correct answer is option B, using the cron service provided by App Engine, publish messages to a Cloud Pub/subtopic. Subscribe to that topic using a message processing utility service running on Compute Engine instances.
Why is this correct? B. App Engine cron service provides reliable scheduled execution, while Cloud Pub/sub acts as an asynchronous messaging buffer. Decoupling the scheduling trigger from the processing instances via Pub/sub ensures high availability, scalability, and reliable message delivery if worker instances fail. Why are the others incorrect? A. Publishing messages directly to Compute Engine instances creates tight coupling and lacks a reliable message queue to buffer tasks during instance failures or traffic spikes. C. Kubernetes Engine cron jobs run inside a GKE cluster rather than providing a managed global cron service, and sending messages directly lacks a decoupled message buffer. D. While using pub/sub provides decoupling, managing cron scheduling via a GKE cluster introduces unnecessary operational overhead compared to using a fully managed serverless cron service like App Engine Cron.
Your company is building a new architecture to support its data-centric business focus. You are responsible for setting up the network. Your company's mobile and web-facing applications will be deployed on-premises, and all data analysis will be conducted in GCP. The plan is to process and load 7 years of archive.csv files totaling 900 terabytes of data and then continue loading 10 terabytes of data daily. You currently have an existing 100 megabytes internet connection. What actions will meet your company's needs? The options are: Option A, compress and upload both archived files and files uploaded daily using the SUDL-M option. Option B, lease a transfer appliance, upload archived files to it, and send it to Google to transfer archived data to cloud storage. Establish a connection with Google using a dedicated interconnect or direct peering connection and use it to upload files daily. Option C, lease a transfer appliance, upload archived files to it, and send it to Google to transfer archived data to cloud storage. Establish one cloud VPN tunnel to VPC networks over the public internet, and compress and upload files daily using the SUDL-M option. Option D, lease a transfer appliance, upload archived files to it, and send it to Google to transfer archived data to cloud storage. Establish a cloud VPN tunnel to VPC networks over the public internet, and compress and upload files daily.
To arrive at the correct answer, we focus on the keywords: deployed on premises, 900 terabytes of data, 10 terabytes of data daily, 100 megabytes internet connection.
Correct answer is option B, lease a transfer appliance, upload archived files to it, and send it to Google to transfer archived data to cloud storage. Establish a connection with Google using a dedicated interconnect or direct peering connection and use it to upload files daily.
Why is this correct? B. Transfer appliance efficiently moves 900 terabytes of offline archived data to cloud storage. A 100 megabits per second connection cannot transfer 10 terabytes daily, requires 9.25 days per day's data. Thus, dedicated interconnect or direct peering provides the necessary high bandwidth direct network connection. Why are the others incorrect? A 100 megabits per second internet connection cannot support transferring 900 terabytes of archives or 10 terabytes of daily uploads, even with compression and multi-threaded SUDL uploads. C. A single cloud VPN over a 100 megabits per second internet connection lacks the necessary bandwidth to support transferring 10 terabytes of data daily. D. Cloud VPN over a 100 megabits per second public internet connection is severely constrained by bandwidth and cannot handle 10 terabytes of daily data uploads.
You are developing a globally scaled frontend for a legacy streaming backend data API. This API expects events in strict chronological order with no repeat data for proper processing. Which products should you deploy to ensure guaranteed once FIFO, first in, first out, delivery of data? The options are: Option A, Cloud Pub/Sub alone. Option B, Cloud Pub/Sub to Cloud Data Flow. Option C, Cloud Pub/Sub to Stackdriver. Option D, Cloud Pub/Sub to Cloud SQL.
To arrive at the correct answer, we focus on the keywords: strict chronological order, no repeat data, guaranteed once FIFO.
The correct answer is option B, Cloud Pub/Sub to Cloud Data Flow.
Why is this correct? B. Cloud Data Flow integrates with Cloud Pub/Sub to deduplicate messages and restore correct ordering, ensuring exactly once processing and strict FIFO delivery required by the legacy API. Why are the others incorrect? A. Cloud Pub/Sub alone provides at least once message delivery, meaning duplicate or out-of-order messages can occur without an processing engine like Dataflow to handle deduplication and ordering. C. Stackdriver, now cloud logging/monitoring, is designed for observability and system monitoring, not for processing or delivering streaming data pipelines. D. Cloud SQL is a relational database for transactional storage, not a real-time stream processing service capable of guaranteeing ordered, exactly once data pipeline delivery.
Your company is planning to perform a lift and shift migration of their Linux RHEL 6.5 Plus virtual machines. The virtual machines are running in an on-premises VMware environment. You want to migrate them to Compute Engine following Google recommended practices. What should you do? The options are: Option A, 1. Define a migration plan based on the list of the applications and their dependencies. 2. Migrate all virtual machines into Compute Engine individually with Migrate for Compute Engine. Option B, 1. Perform an assessment of virtual machines running in the current VMware environment. 2. Create images of all disks. Import disks on Compute Engine. 3. Create standard virtual machines where the boot disks are the ones you have imported. Option C, 1. Perform an assessment of virtual machines running in the current VMware environment. 2. Define a migration plan, prepare a Migrate for Compute Engine migration runbook, and execute the migration. Option D, 1. Perform an assessment of virtual machines running in the current VMware environment. 2. Install a third-party agent on all selected virtual machines. 3. Migrate all virtual machines into Compute Engine.
To arrive at the correct answer, we focus on the keywords: lift and shift migration, on-premises VMware environment, Compute Engine, Google recommended practices.
The correct answer is option C, 1. Perform an assessment of virtual machines running in the current VMware environment. 2. Define a migration plan, prepare a Migrate for Compute Engine migration runbook, and execute the migration.
Why is this correct? C. Following Google best practices for VMware migrations involves assessing the source environment first, establishing a migration plan, and utilizing Migrate for Compute Engine, Velostrata, runbooks to organize, automate, and execute wave-based migrations efficiently. Why are the others incorrect? A. Omitting the initial environment assessment leads to incomplete planning. Additionally, migrating VMs individually rather than using structured wave migrations via runbooks is inefficient and not a recommended practice. B. Manually exporting disk images, uploading them, and recreating VMs is a slow, error-prone manual process that lacks the stream-based migration and rollback capabilities of Migrate for Compute Engine. D. Relying on third-party agent-based methods is unnecessary and inefficient when Google's agentless Migrate for Compute Engine tool specifically integrates with VMware for seamless migration.
You need to deploy an application to Google Cloud. The application receives traffic via TCP and reads and writes data to the file system. The application does not support horizontal scaling. The application process requires full control over the data on the file system because concurrent access causes corruption. The business is willing to accept a downtime when an incident occurs, but the application must be available 24/7 to support their business operations. You need to design the architecture of this application on Google Cloud. What should you do? The options are: Option A, use a managed instance group with instances in multiple zones, use Cloud File Store, and use an HTTP load balancer in front of the instances. Option B, use a managed instance group with instances in multiple zones, use Cloud File Store, and use a network load balancer in front of the instances. Option C, use an unmanaged instance group with an active and standby instance in different zones, use a regional persistent disk, and use an HTTP load balancer in front of the instances. Option D, use an unmanaged instance group with an active and standby instance in different zones, use a regional persistent disk, and use a network load balancer in front of the instances.
To arrive at the correct answer, we focus on the keywords: traffic via TCP, does not support horizontal scaling, concurrent access causes corruption, available 24/7.
Correct answer is option D. Use an unmanaged instance group with an active and standby instance in different zones, use a regional persistent disk, and use a network load balancer in front of the instances.
Why is this correct? D. The application requires TCP traffic handling, which necessitates a network load balancer. An unmanaged instance group with an active/standby topology combined with a regional persistent disk prevents concurrent file system writes while ensuring regional failover and high availability. Why are the others incorrect? A. An HTTP load balancer cannot process raw TCP traffic. Furthermore, a managed instance group with Cloud File Store exposes the application to concurrent file system writes, leading to data corruption. B. Cloud File Store with a managed instance group permits concurrent access from multiple instances, which violates the requirement to prevent concurrent file system access and data corruption. C. An HTTP load balancer operates at layer 7, HTTP/HTTPS, and is incompatible with applications that require raw TCP traffic at layer 4.
Your company has an application running on multiple compute engine instances. You need to ensure that the application can communicate with an on-premises service that requires high throughput via internal IPs, while minimizing latency. What should you do? The options are: Option A, use OpenVPN to configure a VPN tunnel between the on-premises environment and Google Cloud. Option B, configure a direct peering connection between the on-premises environment and Google Cloud. Option C, use Cloud VPN to configure a VPN tunnel between the on-premises environment and Google Cloud. Option D, configure a cloud-dedicated interconnect connection between the on-premises environment and Google Cloud.
To arrive at the correct answer, we focus on the keywords: compute engine, on-premises service, high throughput, internal IPs, minimizing latency.
The correct answer is option D. Configure a cloud-dedicated interconnect connection between the on-premises environment and Google Cloud.
Why is this correct? D. Dedicated interconnect provides a direct physical connection between your on-premises network and Google Cloud, delivering low latency, high throughput capacity, and private internal IP access to VPC resources. Why are the others incorrect? A. OpenVPN routes traffic across the public internet, which introduces variable latency, limited throughput, and requires additional management compared to dedicated cloud hybrid connectivity options. B. Direct peering connects to Google's public edge network to access public Google APIs and services, but it does not extend VPC internal IP addressing to on-premises networks. C. Cloud VPN operates over the public internet, offering lower throughput limits than interconnect and exposing traffic to internet latency variations.
You are managing an application deployed on Cloud Run for Anthos, and you need to define a strategy for deploying new versions of the application. You want to evaluate the new code with a subset of production traffic to decide whether to proceed with the rollout. What should you do? The options are: Option A, deploy a new revision to Cloud Run with the new version. Configure traffic percentage between revisions. Option B, deploy a new service to Cloud Run with the new version. Add a cloud load balancing instance in front of both services. Option C, in the Google Cloud Console page for Cloud Run, set up continuous deployment using Cloud Build for the development branch. As part of the Cloud Build trigger, configure the substitution variable traffic_percentage with the percentage of traffic you want directed to a new version. Option D, in the Google Cloud Console, configure Traffic Director with a new service that points to the new version of the application on Cloud Run. Configure Traffic Director to send a small percentage of traffic to the new version of the application.
To arrive at the correct answer, we focus on the keywords: Cloud Run for Anthos, deploying new versions, subset of production traffic.
The correct answer is option A. Deploy a new revision to Cloud Run with the new version. Configure traffic percentage between revisions.
Why is this correct? A. Cloud Run natively supports revision management and traffic splitting. Deploying a new revision allows you to split traffic between revisions by percentage, enabling a canary deployment strategy directly within the service. Why are the others incorrect? B. Deploying a completely new service and adding an external Cloud Load Balancing instance adds unnecessary complexity, as Cloud Run inherently handles traffic splitting between revisions within the same service. C. Cloud Build substitution variables like traffic_percentage do not natively control Cloud Run traffic splits automatically during trigger execution. D. Traffic Director is intended for service mesh traffic management across Compute Engine or GKE instances and is not used for revision-level traffic splitting natively managed within Cloud Run.
You are monitoring Google Kubernetes Engine (GKE) clusters in a cloud monitoring workspace. As a site reliability engineer, SRE, you need to triage incidents quickly. What should you do? The options are: Option A, navigate the predefined dashboards in the cloud monitoring workspace, and then add metrics and create alert policies. Option B, navigate the predefined dashboards in the cloud monitoring workspace, create custom metrics, and install alerting software on a Compute Engine instance. Option C, write a shell script that gathers metrics from GKE nodes, publish these metrics to a pub/subtopic, export the data to BigQuery, and make a Data Studio dashboard. Option D, create a custom dashboard in the cloud monitoring workspace for each incident, and then add metrics and create alert policies.
To arrive at the correct answer, we focus on the keywords Google Kubernetes Engine, GKE, Cloud Monitoring Workspace, triage incidents quickly.
The correct answer is option A, navigate the predefined dashboards in the cloud monitoring workspace, and then add metrics and create alert policies.
Why is this correct? A. Cloud monitoring provides out-of-the-box, predefined GKE dashboards that offer immediate visibility into cluster health. Adding metrics and creating alert policies directly within cloud monitoring allows SREs to triage incidents rapidly without building custom infrastructure. Why are the others incorrect? B. Installing third-party alerting software on a Compute Engine instance creates unnecessary administrative overhead and duplicates built-in cloud monitoring features. C. Writing custom scripts to stream metrics through pub/sub, BigQuery, and Looker Studio, formerly Data Studio, adds extreme complexity and delay to incident triage. D. Creating a new custom dashboard for every individual incident is time-consuming and inefficient compared to leveraging existing predefined GKE dashboards.
You are implementing a single Cloud SQL MySQL second-generation database that contains business-critical transaction data. You want to ensure that the minimum amount of data is lost in case of catastrophic failure. Which two features should you implement? Choose two. The options are: Option A, sharding. Option B, read replicas. Option C, binary logging. Option D, automated backups. Option E, semi-synchronous replication.
To arrive at the correct answer, we focus on the keywords Cloud SQL MySQL, business-critical transaction data, minimum amount of data is lost, catastrophic failure.
The correct answers are option C, binary logging, and option D, automated backups.
Why is this correct? C. Binary logging records all database mutations, enabling point-in-time recovery to restore data up to the exact moment right before a failure. D. Automated backups capture periodic full snapshots of the database, providing a baseline image required to perform point-in-time recovery. Why are the others incorrect? A. Sharding distributes data across multiple database instances to scale throughput, but it does not provide backup or disaster recovery capabilities. B. Read replicas offload read traffic and offer asynchronous replication, which may result in data loss during failover and does not replace point-in-time backups. E. Semi-synchronous replication helps ensure replica synchronization but is used for high availability failover, not point-in-time recovery from catastrophic data corruption or loss.